Hello everyone, and welcome to episode 7 of the Ropeway Center Report. I'm Billy, and thanks for joining me today. Today's episode is the Ropeway Center Report Road Trip Special. We have covered a lot of cool and interesting ropeway topics, but I thought it would be fun to mix it up a little bit and look at some ropeways out in the real world. It's time to grab my skis and hit the road.
We're standing at the first detachable quad in the world at Breckenridge Mountain. It was built in 1981 by Doppelmayr. They finished their work on November 10th, but the grand opening ceremony was on December 4th, complete with an Austrian brass band, and Arthur Doppelmayr himself flew out for the opening ceremony. It was originally known as the A1 lift. It cost $2.4 million to build, 5,862 feet long, 774 vertical rise in 7.5 minutes. This top terminal had a 500 horsepower GE electric motor with a 7.5-ton Kissling gearbox attached to it, as well as 2 Deutz diesel engines for auxiliary power and chair parking for all of the chairs. There were originally 145 chairs for a capacity of 2,160 people per hour, but that was later upgraded to 185 chairs and 2,800 people per hour respectively. The line had 22 towers from the Maggie down in the town of Breckenridge up here at the C junction. Tom Klink and Butch David at Breckenridge Resort were instrumental in getting this lift built and constructed, as well as getting it all imported from Austria. The load test actually occurred with Coors beer kegs instead of the usual sandbags or water pails, then was actually used in a Coors advertisement. This was the first modern detachable quad in the world. A brief one opened in 1967 in Alpine Valley, Wisconsin, but it only operated for a couple weeks. This lift right here brought ski lifts and ropeways into the modern detachable era. All of a sudden you could cover twice as much distance, have way higher capacities with quad carriers, which had already been introduced, but this was a revolution. Resorts were replacing their fixed struts with longer detachables, and this really kick-started a detachable building boom in the 80s, a landmark lift for the industry.
Here are some historic images of the Quicksilver quad in operation, available from the Information Center for Ropeway Studies. Clockwise from top left, we have riders loading a chair in the lower terminal, chairs loaded with Coors beer kegs as part of the load and acceptance testing, a chair in the top terminal with slave turnaround chain visible, and 2 images of the Doppelmayr double position grip that served as an early predecessor to the more common DS grip.
No trip to Breckenridge is complete without a ride on the Imperial Express Superchair, the highest chairlift in North America, topping out at 12,840 feet. It was built in 2005 by Leitner Palma, and as you might be able to tell, it's pretty windy up here, so it has a lot of features for wind tolerance, including lots of combination towers, and all the towers as well are built in multiple stages. Breckenridge has a lot of other interesting lifts other than the ones I covered. A double loading 6-pack, a gondola with 2 angle stations, and a fixed grip chairlift with a turn in the middle are just some of the interesting chairs that they've got here at Breckenridge. So highly encourage you to come visit. For now, I'm going to take a ride up to 12,840 feet and do some skiing for myself. So I'll see you on the next stop of the Ropeway Center Report road trip. Hello everyone, welcome to the base of Beaver Creek Mountain in Colorado. This is at Arrowhead. This is Chair 17, the Aerobahn Express, a 1988 Doppelmayr CLD 260 high-speed quad. Why are we here today? Well, because in my time off, I am a lift operator here, and this is my lift. Today, on this part of the Ropeway Center Report road trip, we'll go behind the scenes of a lift operator at Beaver Creek.
After a morning meeting, all of the lift operators first have to get to their lifts. This is one of the most exciting parts of the day, since it sometimes means getting to ski first tracks in the morning. For Chair 17 at Beaver Creek, the lift operators are treated to a ride up Chair 12 and a ski down all the way to Arrowhead Village, typically with a great view of the sunrise over the Gore Range along the way. The photos here are pictures I took on one of those mornings, with the top of 17 shown on the right. When we get to the bottom of the chairlift, it's all business to make sure the lift can open on time safely. After taking off ski gear and turning on control power, an operator performs a visual inspection of the terminal to make sure there is nothing unusual or out of place. Second, the operator will establish communication with the top, usually a mechanic who has snowmobiled to the top and already done a visual inspection up there. Third, the lift is started. For detachables, the lift is started at the drive terminal with the reset or ready needed from the return. Fourth, the lift is run on slow for a set number of chairs, long enough for each chair to go over a tower. This is to prevent the lift from being damaged as much as possible if something out of sight up the line is causing a problem. Fifth, the operators will go through a speed ladder, taking the lift from slow to medium, fast, back to slow, and then a normal stop. This ensures that the controls are functional before anyone boards the lift. Finally, the top operator will board the lift and perform a line check. They ride alone and are equipped with a radio, looking and listening for anything unusual on the sheave assemblies, towers, grips, haul rope, and splice, and they'll radio to stop the lift if so. Throughout all of this process, some operators will also be clearing snow from chairs or around the terminals if it has snowed overnight. The next step is to perform static stop checks at both terminals, but before, let's look at the lift controls.
Here's a quick overview of our lift controls. We've got our control power right here. Our speeds, slow, medium, and fast. Reset if you've got a fault, and ready when the lift is ready back to run. Our stops, normal stop, service stop, and emergency stop. This lift, you override the anti-collision every time upon startup from a stop. That's just part of the operating procedure for this lift. Signal to send a beep to the top operator, and then some maintenance controls like override the approach rail and override the tension. Here you can see a schematic of what's going on here. Watch the proxies light up. You can see 2, 3, 4, and that corresponds to that chair right there running through the terminal. And then this is our stop board. So this will light up. We're all green right now. We're running. We're good to go. And then as soon as a stop comes up, say we have a stop gate right here, that light will turn off. This light will turn on, and that's how you can find which stop. Or say stop buttons right here, this light will turn off, this light will turn on. You can follow all the green down to which green is off, and that's how you know where the stop is.
Static stops verify that various stop circuits on the lift are functional and indicating before any member of the public boards the lift. Each static stop has to be tripped and reset in order for the lift to open. I wasn't able to grab a video of static stops, but these are pictures of some of the stops that are checked every morning at the bottom of chair 17. Top left is a proximity switch, which is checked with a piece of metal to show that it lights up on the board. Bottom left is the grip gauge paddle, which is on the outgoing and incoming sides and moves from its default position out towards the line. This stops the lift if a grip is improperly attached in forward or reverse operation. The middle image shows the carriage limit wand, which is a wand that is tripped if the carriage position is out of the manufacturer's specified tolerance range. The top right image shows the maintenance cord, which is pulled to trip and will get triggered if anything or anybody falls into the area of moving components in the tire banks. The bottom right image is a maintenance lockout switch. Other static stops are the normal and emergency stop buttons on control panels, on the terminal masts, and operator pedestals. Operators will also take measurements during this time, such as carriage position and tension pressure, to be recorded on the daily lift log for reference.
So we've done all our static stops. Now we're going to do our moving stops. So first I'll do the emergency stop on slow. You see the emergency stop circuit stops. Restart the lift. This is an older lift, so it doesn't have a touchscreen, but we go off these stop circuit light boards here. We've already tested our normal stop as part of the operating procedures in the morning. We also hold this override anti-collision every time the chair starts up at the very beginning. So now we'll do our service stop on slow once again. That looks good. Like I mentioned before, we already did our normal stop, so we've done the emergency stop and the service stop. And now we'll take the lift to a fast and do a check the stop gate if someone's coming through the downhill part of the line. So watch this light right here, and you'll see it light up when I go trigger the stop gate.
So that's all good. Hey, this is Lilly at the bottom. All my movements are good. Ready to do loops. Let me know when you're ready. Alright, loop 1 coming down. And coming back up. All good? Alright, loop 2 coming down. And coming back up. Sweet. The last one we got to test is test all our proxies. So I'll override this anti-collision and hold down this test switch. And see those lights, red lights light up. That's an indication that we've got the counterfaults working. And you can see as the chair is going through the exit side of the terminal, it'll light up all these counterfaults when I'm holding down this test button, indicating that all these proxies are reading. So all of it's light up, so release the test switch and the button. And the lift stops, so all of our proxies work, and the lift is ready to go. Those are all our moving stops. So as we look inside the control panel here, we've got all our relays for the low voltage controls. And then up here we got what I was testing a little bit earlier, which was our loops. So this is a redundant derail system. So since this lift operates at around 1,000 feet per minute maximum, we have to have 2 systems to make sure the haul rope is on all of our towers. We've got proximity switches as the main, as well as brittle bars as a backup with, since it's a Doppelmayr, those red wheels as the drop sheave. And if the haul rope were to come off, the heavier weighted red wheels would drop and cause a brittle bar to break. These are tested every morning, so we make sure that this current of electricity is why it's called a loop, running through all the towers. If a prox is triggered or if a brittle bar breaks, this will stop the loop and stop the lift. And again, the redundancy is to ensure extra safety on lifts that move over a certain speed. So that's all tested. The lift is ready to go, and we are ready to operate for the day. I wanted to give everyone a sense of what it is like to be around the lift while it is running. The first video clip is from the point of view of an operator standing at a control pedestal at the load board. The next 2 clips after that are filmed from inside the terminal during a maintenance check, where operators go into the terminal during the day and perform a visual inspection of the lift and look for any potentially unsafe or damaged equipment to report to maintenance. Things are moving very fast and there are lots of rotating and moving components, so you want to use extra caution anytime you are in a lift terminal during operation. Look for important components we talked about in episode 4, such as the tension rams, bow wheel, and actuating rails. So that's pretty much it for us all day. Once we've got the lift ready to run for the public, we will help people load, make sure stop or slow the lift if they fall accordingly, with a special emphasis on making sure kids and adaptive skiers are safe and helping them get on the chair safely, and helping the public enjoy these beautiful mountains. And if you're lucky, sometimes you get to ride the lift yourself.
and go on a rad break, which is what I'm doing right now. Some skiing in the middle of the day, a little break, which is pretty fun. So hope you guys enjoyed this look into a day in the life of a lift operator, and I'll see you on the next stop of the Ropeway Center road trip. Welcome to the next stop of the Ropeway Center Report road trip. This is Sun Valley, Idaho, home of the world's first chairlifts. Right now I'm at Dollar Mountain. Home right behind us, we've got the $quarter and dollar chairlifts, both Doppelmayr C-Tech Uni GS detachable quad. But this right here was the site of one of the world's first two chairlifts, built in 1936 by Jim Curran on Dollar Mountain, running up the exact same lift line that the current quad rolls on. See episode 5 for more about the origin of the chairlift and Jim Curran's incredible story. But today we'll be exploring Sun Valley, Idaho, and some of the history of the world's first chairlifts.
Here's a better look at how Dollar Mountain has changed over time. The picture on the left is the original single chair at Dollar, built in 1936, compared to the image on the right of the current high-speed quad up the same line, built in 2007. There were two lifts on this line in between these two, a more modern single chair built by American Steel and Wire, and a Jan double chair.
After the original chairlifts were built on Dollar and Proctor Mountains in 1936, in 1937, the third chairlift in the world was built at Red Mountain here in Sun Valley. And it still stands today, basically in the same shape that it was back in 1937 when Jim Curran and the crew at American Steel and Wire built this lift. Red Mountain was considered the beginner area, although you can see it's pretty steep, and also housed the ski jump for Sun Valley, which you can still see the remains of sitting up on the mountain. This was a converted former J-bar lift that was converted to a single chair. There's a lot of unique things here. The Sun Valley staff has worked really hard to actually upkeep it over the years. They've upkept both the lift houses, all the chairs are still on the line, and all the towers are still up. So now we're gonna go take a tour of this extremely cool piece of ropeway history. Let's go over some stats of the Red Mountain single chairlift, built again in 1937 by Jim Curran and Company. It's a top drive bottom tension lift. It's 1,860 feet long with 600 feet of vertical rise. The lower assembly here is movable for tension. We'll discuss that in a little bit. 25 horsepower drive up top, 60 single chairs, 3/4 inch diameter haul rope cable, as you can see right here, with shivs that are just steel wheels. You don't have any of those rubber shiv liners like we see on modern lifts, along with these wooden towers that we can see going up the line, and it had a capacity of 216 skiers per hour. So let's go over some features of this single chairlift from 1937. Again, the third lift in the entire world, third chairlift. Behind me we have a counterweight, which is really similar to what you see on a lot of fixed grip lifts that are operating today. The difference here is that the counterweight for tensioning did not move a bullwheel carriage like we see now. It moved this entire platform on a set of rails. So you can see here, this is on a set of wheels, and this whole platform moves back and forth. The entire load terminal moves, as opposed to just the bull wheel on a carriage up top. Obviously that presented some design problems because during a season with heavy snow loads, or even as you can see right here, there was enough snow to block up the track and prevent the lift from having proper tensioning, so that they had to dig it out all the time. So as we're hiking up the lift line here to go check out the top terminal, one thing you might have already noticed is that the chairs are really close to the ground. There's not even any snow, and you can see I'm not very tall, but I can almost reach up and touch it. So there's two reasons why that was. First, the engineers who built this, when they built it and drew it up back in Omaha, they didn't know how much snow loads to expect. So the first year, especially on the Dollar and Proctor chairs, they really had to dig out almost a trench to run the lifts through when there were big storms. And so this lift, they had only 1 year of snow data to work off of, so you can see it's built pretty close to the ground. But this was also done partially intentionally. They were afraid that people would get to the top and get on the chairs and be afraid of heights and be afraid of being up tall. And they also wanted it to be that if something happened to the lift and someone jumped or fell off, that they would be okay. So this was a very early design, almost intentionally, with the chairs this close to the ground. Obviously on modern lifts, that has been changed.
Here's some additional pictures of hiking up the lift line at Red Mountain. It is pretty surreal to be around a chairlift from that era that is basically unchanged, especially after riding modern detachables over at Bald Mountain earlier that day. Two things I want to note here. It was very windy for some of these next videos, so be prepared for that. And in the final video clip from Red Mountain, I mistakenly say that the grips on this lift are pretty similar to modern fixed grip lifts. I realized that this was incorrect after taking a closer look at the grips. These grips are more of a bolt-on clamp style, rather than using springs to provide the force as we are used to today. I apologize for this mistake, and I didn't catch it in time to correct it in a new video while I was still in Sun Valley.
Welcome to the top of the Red Mountain Chairlift. After 1,800 feet of length and 600 feet of rise, we are at the top of America's oldest standing chairlift. As you can see here, this is the American steel and wire style single chair terminal, which lifts at Mount Eac in Alaska and Mad River Glen in Vermont still have going and rolling to this day. This is where guests would have unloaded and gone down for the runs or to the ski jump. So let's go over some features of the top drive terminal of the Red Mountain Chairlift. Here we see our breakover towers with those shivs with no liners, just steel shivs going over the top terminal structure. We can see the bull wheel, which has a rubber liner in there. Going around, we'll check out the drive setup. There is the electric motor for the drive, and then up into this drive shaft here, and then the coupling to the bull wheel, and then it's the bull wheel. That's how she would spin. Cool note here, you see this is a brand new lift house that was pretty recently installed by Sun Valley Lift Maintenance. Carol Holding, the wife of the owner of Sun Valley Resort, requested that this lift be kept in its historic state as close to as possible, and the Sun Valley Lift Maintenance crew over the years has done a really good job of upkeeping. As you can see, that the chairs are still on the line, there's still tension. This thing has not been vandalized. Pretty close to original shape, which is just a really cool relic and a really cool piece of Ropeway history. So kudos to Sun Valley Lift Maintenance and everyone who has helped keep this lift in historic shape over the years. So that's it from Red Mountain, from one of the chairlifts that started it all. Chairlifts have been built around the world, and this technology was part of it, the original thing. You can see that this is just so similar to even modern fixed grip chairlifts. The grips are pretty similar, the drive system is pretty similar, the tensioning, counterweight is pretty similar. This lift even ran to similar speeds as modern fixed grip lifts. Really a testament to the amazing work of Jim Curran and the engineering team at Sun Valley and American Steel and Wire. That's it from the Red Mountain Chairlift. You can see behind me Sun Valley's famous Bald Mountain. Thanks for joining me, and we'll see you on the next stop of the Ropeway Center Report road trip.
The final stop on the Ropeway Center Report road trip is the Estes Park Aerial Tram. I was lucky to receive a full behind-the-scenes tour of this system from Adrian, the general manager of the tram. Shown here are the pictures and videos I took from the tour with information provided by Adrian. The Estes Park Aerial Tramway is believed to be one of, if not the, oldest operating lift in North America and one of the oldest operating aerial trams in the world. It was built in 1955 by Heron Engineering, led in chief by legendary tramway engineer Bob Heron. Heron Engineering built over 70 lifts, including Aspen's original Lift 1, the groundbreaking double chair at Berthoud Pass, and trams at the Royal Gorge and Heavenly. It is a reversible or jig-back system, actually the first passenger jig-back to be built in Colorado. It has no towers and is one long free span, from the bottom tension terminal in Estes Park to the top drive terminal on Prospect Mountain. The free span is 2,600 feet long with 1,035 feet of vertical rise, reaching a maximum height above the ground of around 180 feet. The tram is purely for sightseeing and to access the cafe and some other facilities at the top. The Heron family still owns and operates this lift. Save for the addition of some electronic safety systems in the 1990s, the tram is essentially unchanged from when Bob Heron first designed it. One of the more unique aspects of the tram is the different types of ropes it uses, 4 in total. The tram has a 3/4 inch haul rope and a smaller 5/8 inch tail rope. The haul rope travels through the drive station, while the tail rope travels through the deflection bull wheels at the return. Rather than a splice, each end is secured to the tram cabin with a mechanical swage socket on the carriage. The track ropes are also unique. Each cabin runs on one track rope, but the 2 track ropes themselves are different. The west track rope is original from 1955 and is a unique type of wire rope called track strand or bridge strand. The east track rope was installed in the 1960s and is a locked coil wire rope. The ropes are inspected routinely with magnetic testing. The long lifespan of the track ropes can be attributed to proper lubrication over the years and the lack of towers or heavily loaded cars, which prevents any major deflections from creating significant fatigue cycles. As such, the east track rope is heavier per foot than the west track rope, so the counterweights are slightly different weights to compensate. 48,000 pounds for the west track rope and 52,000 pounds for the east track rope. The track ropes are deflected from the line to the counterweight pit using large saddles and rollers, shown on the right. The rollers move back and forth on the saddle structure so the counterweight can adjust while the cabins are moving, often by several feet on a trip. Rather than one large concrete block, the counterweights here are composed of smaller chunks of concrete and steel. This made them much easier to adjust and fine-tune when the lift was first built. The tail rope has a very interesting return setup. A large deflection sheave, shown on the top right, deflects the tail rope from the loading dock down into the counterweight pit. The two images on the left show the large deflection sheave attached to a different counterweight than the track rope counterweights, obviously, that adjust up and down for tension. From here, the tail rope travels back up out of the pit, diagonally through the building, and then back up to the other side of the load dock. The bottom right image shows two of the deflection sheaves used to accomplish this. The very bottom one is actually an original cast iron sheave wheel from when the lift was built. The other sheaves have been replaced over the years, but none of them use rubber sheave liners. They all have a machined groove for the haul rope. The sound is quiet as the tail rope moves through the station. Take a listen.
Track ropes.
Yeah. I just can't believe how quiet it is. It's a whisper quiet.
And they're double tapered roller bearings in these things, so they run dead quiet.
Yeah.
The cabins were originally specified to hold 12 passengers, but typically only 8 to 10 people are loaded. The cabins were manufactured by an aircraft company in Denver and originally painted yellow at the beginning, before they were changed to the iconic red shortly after the lift opened. Each cabin has 8 carriage wheels, which do have rubber liners. Large wooden extensions at both terminals corral the cabins into the load and unload docks. An attendant rides in the cabins with passengers and locks the doors from the inside for the ride up. The cabins are also equipped with track rope brakes that are activated either automatically if a haul or tail rope connection fails, or manually by a handle in the cabin. These release Belleville washers to trigger a clamp on the track ropes, securing the cabin in the event of a failure of the haul or tail rope. Rope-down evacuation procedures are also practiced annually. As we reach the top terminal, the track ropes pass through saddles in the top terminal structure before traveling to the bollard and anchors, while the haul rope deflects down to the drive bull wheel. The saddles are directly above the motor room. The bollard has 3 windings for each track ropes and large plate clamps to anchor the track ropes to the mountainside, although most of the necessary holding force comes from friction in the wrap. The Tram is powered by a unique 50 horsepower DC electric motor, rather than an AC electric motor as is common today. Since AC power is provided to the top terminal, there is an AC-DC generator used to power the motor. Listen to the incredible noise the generator makes when it fires up.
Okay. Yep.
On the drive shaft from the electric motor to the gearbox, there is a high-speed disc with service brake shoes acting on it. The gearbox is an 18-to-1 speed reduction gearbox with a large coupling to the bull wheel, which stands upright vertically just behind the operator desk. The image on the left shows the coupling belts from the auxiliary motor to the gearbox. All of the brakes on the Tram use mechanical linkages. The service brakes also have a gravity backup, shown on the top left, where the large red weight will fall if the hydraulics fail and automatically stop the lift. That hydraulic fork there you see is kind of pressing up against it. The massive drive bull wheel, which is believed to come from a Leshan mine tram, is shown on the right and has a massive mechanical brake linkage that can be used to apply stopping force directly. The bull wheel liner is made of unique wooden inserts that are specially cut and hammered into place. Some other interesting drive components are shown on the bottom left, including a really unique leather coupling used on the high-speed disc and the Ford gasoline engine that provides auxiliary backup. This is an overview video of all of the Tram components in operation. of the most interesting parts of this entire lift is the Lilly Hoist Controller, Lilly being the manufacturer of the controller. This incredibly unique piece of equipment essentially acts as a mechanical brain for the lift. Keep in mind, this lift was built in the days far before modern electronic controls. The hoist controller is tied into the bull wheel with a chain and has a number of features. It detects for overspeed, either out on the line or while approaching the terminals, with a flyball governor that takes advantage of centrifugal force. The system also shows the position of the cabins on the operator console using a large lead screw and sounds a bell to alert the operator of the approaching cabin. The large red wheel, visible here on the left, rotates directionally with each trip. The hoist controller is a fascinating collection of mechanical linkages and devices to control the lift, and is like nothing I have ever seen on a lift before. Here are 2 videos of the hoist controller in action. As I mentioned before, there are few electronics on this lift, so the tram control is entirely manual. There is a low-voltage electronic stop circuit for features like ensuring the doors are shut. There is no comm line, so the low-voltage controls are transferred through the ropes themselves. The ropes are accordingly insulated from the rest of the machinery, and wire brushes on the cabin connect it to the low-voltage circuit. If the low-voltage circuit gets outside of a designated operating range, the lift will stop. There is also what was added in the 1990s, which is a PLC that performs electronic safety monitoring, such as proof of torque when the lift first is started. An operator will sit at this drive desk, shown in the image on the left. After verifying that the bottom is clear and switching the direction, the operator will start the tram. The speed is controlled by the large knob sitting on top of that red plate. After moving slowly out of the station, the operator can turn up the line speed. The tram has a maximum speed of 1,400 feet per minute, read out on the large center dial, but typically runs a little slower than that. When the operator hears the ding of the bell on the hoist controller, they will slow the tram down to below 250 feet per minute to avoid an overspeed, and gently move the tram to the docking position and stop it. Again, all of this is completely manual. If the operator needs to slow the lift down more than the dial will allow, say with a fully loaded downhill cabin with nobody coming uphill, they can use the brake foot pedal shown on the top right to additionally brake the lift. This controls the mechanical brake linkage right on the bull wheel. I was lucky enough to run the tram for a couple trips myself, as shown in this video. We were running at 500 feet per minute since the gearbox was not up to temperature yet on a cold morning.
So then wait till it gets out to that orange mark, right?
Yep. You just need to be under 250.
So you can go a little faster than
Yeah,
that.
you can get some gusto.
Now it's all good.
The Estes Park aerial tramway is a truly unique lift and a hallmark of solid engineering. The entire lift has a minimum factor of safety of 10, with many components far exceeding that. This is impressive considering Bob Heron only purchased the electric motor new for this lift. The rest of the components were things he had around his engineering company's shopyard. There are no spare parts from the manufacturer for this lift. If a part breaks or wears, then the maintenance team at the tram uses the original hand-drawn prints to get it remanufactured. It is very cool to see original components like the cabin, west track rope, motor, and gearbox unchanged from their installation in 1955. The entire team at the tram takes a lot of pride in maintaining this machine. Although it is far different from the other lifts in the state, the tram still receives yearly inspections from the CPTSB and passes with flying colors. After being closed last summer due to COVID, the Estes Park aerial tramway will be open this summer from Memorial Day to Labor Day with health and safety protocols in place. I highly encourage you to take a visit and see this awesome piece of ropeway history in action. A very special thank you to Adrian and Patrick with the Tram for giving me a great tour and showing me around. Here are the sources I used to put together the information for today's episode. That's all for the Ropeway Center Report road trip. I'm left with a lot of great memories and 2 nice souvenirs. This hat, which has the date Jim Curran built his first chairlifts and when Sun Valley was established, 1936. And this retired mechanical suede socket from the Estes Park Aerial Tram. This was for connecting the tail rope to the tram carriage. And you can see the 5/8" tail rope right there. Thank you very much for tuning in today. I hope you enjoyed getting up close and personal with a variety of really cool ropeways. Our next episode will be about mine trams, which is one of my favorite topics. We'll look into the history of this unique era of ropeways that saw hundreds of trams sprout up across the American West well before the chairlift was born. Thanks once again, and I'll see you on the next episode of the Ropeway Center Report.